Okay, guys, so you should have already watched the beginning of the L8 lesson. Again, this is just if you were absent today due to the ASVAB or anything else. We only did 2 questions together beyond what it was in the original video. And then we did this last AP question together. It's going to be a doozy, but I'm going to kind of walk you through it. We did it together kind of in groups in class on whiteboards, so we'll get there. So what we talked about again in the first L8 video was that there's lots of different things we can find when talking about projectile motion. Depending on the direction you're looking at, tells you whether or not you're going to be looking in just the X direction or just the Y direction, or possibly having to put both of them together. So again, this slide here talked through where you're looking depending on what you want to find. So we'll try and kind of drill that in with these 2 examples we're going to do here. So it says a long jumper jumps the initial speed of 10 meters per second at an angle of 45 degrees. So we always want to start off by drawing that picture. So take a second and draw this picture. It's going to be a triangle. Yeah. What's that going to look like? Well, when they say initial speed, that means specifically along the pathway. This is their total speed along the pathway. So that's the hypotenuse, 10 meters per second, at an angle of 45. So here's my 45. Now, again, thinking about the vectors to break this down, if I have an arrow going off this way, yeah, I could break this into right direction motion and up direction motion. Again, notice how my arrows compare tip to tail. These are my arrows that give me my total speed. Right and up would give me that direction diagonal. And this is 45 degrees. So here's my initial picture. So now I want to look at what we're trying to find. It says, what is the maximum height? Now, we know something. Again, he's going to go like this. Yeah, so his max height is obviously right there. Yeah. We know something about the max height that still applies in this case. What do we know about our velocity when we're at our maximum height in a projectile or a jump or whatever? Your velocity is 0. However, more importantly, it's a certain component of your velocity that's 0, because only one of those components that I'm dealing with here are going to be affected by gravity. So when we say our velocity is 0 at the max height, we specifically mean your y velocity is 0. Remember that your x velocity is constant. This x velocity is not going to change the entire time. The y velocity will change because that's affected by gravity. So what we're going to do here is we're only going to look in the y component to find the max height. So let's go ahead and lay out our variables here. 1, 2, 3, 4, 5. Sorry, that's terrible. Now, what I'm going to do here is I'm going to add a little y subscript to try and keep my brain straight. So I'm going to have x initial, but only in the y direction, because position can be in the y or it can be in the x. So since I'm talking about the y direction here, I want to be careful that I'm only looking this way. So x initial in the y is here on the ground. Yeah. My x final in the y would be like up in the air, right? So I'm looking up and down only, my initial to my final, yeah, because I'm looking in the y direction. I have A, I have T, I have B initial in the y, and I have B final in the y. So let's go ahead and start breaking this down here. Now, what we want to do, and I talked about this in the last video, we have to be careful of our direction of positive. Now, typically, again, this is a choice, but do we see how we have an initial, and again, I'm going to clarify here, this would give me my initial, yeah, velocities off of this 10, because that 10 is going to change throughout the motion, so these are my initial velocities. Since I'm going up, I'm going to go ahead and choose up to be positive. I could choose down to be positive, but because I have an initial velocity upwards, I'm going to choose up to be positive. So we do need to find this initial velocity. So take a second, do the trig. Right now, we're just trying to find Vy initial. Do the trig, what is that? Okay, so that means that 45, here's my angle. VYI is my opposite. Here's my right angle. That makes 10 the hypotenuse. Looking at SOHCAHTOA. Oh, right there. That's the SO in SOHCAHTOA, right? Opposite over hypotenuse. So I've got sine 45 equals VY initial over 10. I can think about this like cross multiplying. I'm going to multiply the 10 over. I've got 10 times sine 45 equals VY initial. Now, I'm going to be drilling this home over the next couple units, especially, but this is a very, very common thing to happen. If I have the hypotenuse and I have the opposite, I know I'm going to end up here at my hypotenuse times my trig function equals what I'm trying to find. So I forgot to pull up Desmo, so I got to pull this up here. So I've got 10 sine 45. Okay, I got 7.07. So my VY initial is 7.07 meters per second. And that's going to change because of gravity. Now again, because this is upward initial, and I designated positive to be upwards, this is going to be positive here. So I'm going to put my initial here, 7.07. Okay, I want you to take a second now and keep filling out the rest for what we have, yeah? And make sure you have your question mark where you want to put your question mark. Be careful the direction of positive for these things. Take a second, fill out the rest of your variables. Okay, so my x initial, I'm going to go ahead and call that 0, yeah? And it says, what is the max height? So I'm looking for my final height, yeah? And I'm deciding to call my initial height 0. And that works because this is my direction of positive. So here's my x initial y, that's 0. X final y is what I'm looking for, yeah? And that'll be positive. Now, because I'm calling up positive, gravity needs to be negative. If you did not call that negative 10, it's going to screw things up. We know one more thing, because at the max height, our y velocity is 0. So looking at these variables, what formula are you going to be using? Time is blank, so we're using the time list. So take a second to do so if you haven't already. We're solving for x final y, and then I'll do it here. Okay, so I have velocity final. So at this point, I'm going to go ahead and take off the subscripts for the y, just because it's a lot to write out. And I know that I'm looking in the y now. I got that all set up. So velocity initial squared plus 2a x final minus x initial. You can skip ahead in this if you'd like to until the end. V final is 0. Right? Because again, I'm looking at the peak of my jump. My velocity is 0 there. I've got 7.07 squared plus 2 times, this needs to be a negative 10. If it's not, it's going to screw things up. I'm looking for x final minus my initial position is 0. So let's do a little math here. I'm going to go ahead and just square this exactly. Oh, that's 5. Is that right? That can't be right. It's not 5. Okay, so let's see. Enter, answer, there we go, squared, 50, there we go. Okay, this is 50, so I'm gonna use this exact. If you use 7.07 and round it off and square it, it's gonna give you a little bit different, that's okay. Minus 20, and then this is gone, x final. So I'm gonna minus that 50 over. I've got minus 50 on this side, I've got negative 20 x final. Divide by negative 20. Okay, so you should get x final is 5 divided by 2, 2.5. Yes, meters. So my total height at the peak of my jump off the ground, again, I'm going to go like this, because it's projectile, but my peak right there is 2.5 meters. Okay, so once again, we had to be very careful about a lot of things. Because I was looking for the height, you only look in the y direction. If I'm looking at height, I only look in the y direction because height is a y direction. I didn't even look at the x direction at all for this question. Okay, let's go ahead and try the next one. So it says, how far does the long jumper jump from where he started? So think about this. Yeah, how far does the long jumper jump from where he started? It's going like this. Is this question now looking in the y direction or the x direction? How far does the long jumper jump from where he started? This is x direction. So now I'm only going to look in the x direction. And what do we happen to know about the velocity in the x direction? It is constant. It does not change because it's not affected by gravity. It's perpendicular to gravity, so it's not affected by gravity. So if we look back to that slide there, when, again, gravity doesn't affect the x component, so we can think of the distance traveled. Hey, that's how far we're going, distance traveled this way. I tend to think of this as d equals rt. That's the basic, your distance equals your rate of speed. That's what r is. R is your velocity in this case, times your time. Again, r is the x component of velocity. So I'm thinking of this as d equals rt. So I'm looking for my distance. I need to know my x component of velocity, and I need to know my time. So there's two things here. I'm going to have you start off by finding the x component of velocity, because we have this little picture right here. We can find the x component of velocity. Hopefully you realize something and you don't have to do extra work. Take a second and find the x component of velocity. Now, because this is a 45-degree angle, I know that the x component is going to equal the y component. If it's a 45, 45, 90, the x and y's are the same. So I can say that right here. Vx initial is going to equal Vy initial because it's a 45, 45, 90. If it were not, I would have to do trig again. But it's going to be 707. So my distance, my velocity here is 7.07. But I need the time. So here's the thing. Looking back again to this slide, let's fill in these blanks here. Right there it is. Time can only be determined in the y component for projectiles. The reason why is the only reason you hit the ground is because of gravity, right? The time of travel, i.e. the time it takes to hit the ground, only occurs because of gravity. If there were no gravity, if I threw something, it would never hit the ground, right? So we need to solve for time in the y component. Now, thankfully, I've already got all of this stuff in the y component. So I'm going to recopy these variables here and change a couple things. So I'm solving for time right now. Solve for time in y. 1, 2, 3, 4, 5. I've got x initial in the y, careful. I have x final in the y, trying to keep this all straight. V initial in the y, and V final in the y. So take a second, recopy of your variables, but change your question mark. What's our question mark here? Now that I'm trying to solve for a particular thing. Okay, well, my x initial in the y is 0. We did solve for our x final, yeah, 2.5. So I'm going to go ahead and put that there because I do know that now. A is still negative. T is the question mark. And then V initial was the 7.07. Now, technically, I actually know my V final in the y, but I'm going to leave that blank so I don't confuse you because that's enough information to solve for time. So take a second, look at those variables. What formula are you going to use to solve for time? Actually, I lied. We could do it this way, but it's going to require us to, okay, pause. We could solve for time this way. Really quickly, I'm going to talk through it, but I'm not going to end up solving the whole thing. Could solve for time this way because what formula should we be using here in this case? You could use the position formula. This is x final equals 1/2 at squared plus velocity initial t plus x initial. Take a second and go ahead and fill it in, and then I'm going to talk about why it's going to be a pain in the butt, and if I can recognize something else, I can solve for time differently. Okay, so actually, no, I think I want to show this. Okay, there is a different way I can solve for time. We're going to go ahead and do this so that I can drill home again how you can use your calculator and kind of save you some pain. So our x final is 2.5. We have 1/2. A is -10. I'm looking for t squared. And I've got initial velocity. This is what screws us up here. And then my x initial is 0. So here's what screws us up. I have a t squared and a t. When this happens, make a note here. When you have an initial velocity is what happens, because that t ends up not canceling out. You need to graph and get the roots. That's how we solve. Get roots, again, or zeros, or whatever you want to call them. Yeah, x-intercepts, yeah. So I'm going to go ahead and simplify this here. So I'm going to move everything over to one side because that's what we do need to do in order for this to work out. So I'm going to do a couple things here. I'm going to move the 2.5 over, and then I'm going to simplify this 1/2 times the -10. So moving the 2.5 over leaves 0 on this side. I have 1/2 times -10. I got -5t squared plus 7.07 t. Again, that's what screws us up. And then I still have, again, this -2.5 that I moved over. Okay, so what we're going to do is I want you to go either to Desmos if you're at home probably doing this. If you have a graphing calculator, you can use that. But graph that, find the zeros, and then we'll get our answer from there. Okay, so I'm going to Desmos here, so I need to go back to Desmos graphing. I have y equals -5t squared plus 7.07t minus 2.5. Okay, so here is my graph. Is that right? That should be our time. 0.707. That would make sense, I suppose. 2.5. T equals 0.707. Because that is our 0. Yeah, it's wherever your x-intercept is at. And that should make sense, actually. That should work out there. So 0.707 seconds, we can say that. So that is our time. That should be correct. Let me do a quick checkaroo. Final velocity would be -707. Minus E. I messed this whole thing up. I'd want that to be 0, wouldn't I? Okay, crap. I gotta go back and delete this whole thing. That's fine. I'll delete this whole thing. Okay. That's why it needs to be doubled. Okay. Trying to think where I left off here. Okay, so now we need to solve for time. Now here's the thing. Again, that time is only solved in the y component. We saw that again back here. Sorry, I made a mistake, guys. I had to cut out a lot of this. So we talked about how time can only be determined in the y. We got to be careful here because we need to find the total time of flight. So again, to find the total time of flight here, I'm going up and back down. So I need to look in my y direction, yeah? In my y direction, here is my x initial, and here is my x final, right? Total time of flight is going up and coming back down. So looking up and down, what's my x initial in the y direction? Well, it's 0. I go up and I come back down. What's my x final in the y direction? 0, because I'm going up and coming back down. So we have to be careful here. In this last slide, and this was the mistake I made, we only referenced getting up to the peak, yeah? So looking at example 2, that's only half of our trajectory, yeah? We do go up and come back down. And we need to look at that entire motion here because I am looking at the entire motion. Yeah, I want to find how far he went out by the time he hits the ground again. So looking at our variables, at 1, 2, 3, 4, 5, whew, looking in the y direction only. Again, total time of flight is only in the y. So I have x initial y, I have x final y, I have a, I have t, I have velocity initial in the y, and velocity final in the y. Let's take a second and go ahead and fill out these variables. Remember, we're trying to find time to be able to go back to answer this pretty simple question otherwise, yeah? So take a second to go ahead and do so. Okay, my x initial in the y is 0. My x final in the y is 0. Once again, if I am calling upwards to be positive, I need to call acceleration negative. Time is question mark. We're trying to figure that out. My velocity initial in the y we already found was 7.07. So technically, I know my final velocity in the y, but I want you guys to do it this way with these variables. If you know what the velocity final in the y is, I might show that at the end, yeah? But go ahead and do it this way. What equation are we using with these variables? This is the position formula. These 5 variables are always the position. X final equals 1/2 at squared. Velocity initial t plus x initial. Okay, so let's go ahead and fill these in. You're going to notice something. Fill them in and then pause. Okay, so I've got 0 equals 1/2, excuse my terrible handwriting, negative 10 t squared, that's what I'm looking for, plus my velocity initial. Okay, so this is going to screw things up here because 0 equals, I'm going to go ahead and simplify this, because I have t squared and I have t. And that's what I got. Now, there is a way to solve this algebraically, actually, because I just, I don't have anything being added here, and I've got nothing on this side. However, I want to show you how to do it graphically because it does make your life pretty easy to do it graphically. So what we're going to do is we're going to graph this when you've got a t squared and a t, graph and find the roots. Again, roots or are zeros or x-intercepts, yeah, whatever you want to call them. So let's go ahead and go to Desmos. Figure this out here. Okay, so I went ahead in Desmos and I plugged in my equation. Now again, I'm going to do y equals, right? I'm not going to do 0 equals because I know where to look for where 0 equals for my y. So I've got 2 answers. Obviously, I'm starting on the ground and I end back on the ground. So 1.414, that's my root. That's going to be the time. 1.414 seconds. Now, that is just the time of flight. That is the time it takes to go up and come back down. Look back up to the top of this question. I haven't answered the question yet. We got to do one more thing. Look at what I have. Where does it go? Well, okay, I found the time. So 1.414. It's going to get plugged in there. So I've got 7.07 times 1.414. Okay, about 10-ish, yeah, and that makes a bit of sense here. I'm going to go ahead and round this up to 10 meters. It ended up being 9.99698, yeah. That's going to be my distance sideways. So I reach a peak of 2.5 meters, and I go sideways 10. Because this took so long for this video, if you would like for me to go over this one with you, you can come in. I can walk you through it. This is an AP style, like free response type question, and it is tricky. But It's not going to be the majority of what you're going to see. And so if you would like some help with this, it's very abstract and we haven't done anything. Notice there's no numbers. So if you were absent today, you can come in. I can help you through that one. You're not going to have anything quite like that on your homework.